The graph of f where f of x equals x times 2 minus root x, and part of the graph of g where g of x equals 2x as shown below. Find f dash of x. To find f dash of x, it's easier to expand f of x and write it in power form. And so we can write f of x is equal to 2x minus x times root x. In power form, this is going to be 2x minus x to the power of 3 on 2. And so f dash of x is going to be 2 minus 3 on 2 x to the power of a half. The tangent to the graph of f at the point B is perpendicular to the graph of g. Find the coordinates of B. If the tangent line at some point B is perpendicular to the line G, then we can state that the gradient of the line G times the gradient of the tangent line is going to equal minus 1. We know the gradient of the line G is equal to 2, and so we can write this as 2 times the gradient of the tangent line is going to equal minus 1. And so the gradient of the tangent line is going to equal minus a half. What this means is that the gradient of the function f at some point is going to equal minus a half. To find this point, we need to let f dash of x equal minus a half and then solve for x. We know that f dash of x is 2 minus 3 on 2 times the square root of x, and so this is going to equal minus a half. Rearranging this to solve for x, we can bring the minus half to the left hand side and move the 3 on 2 root x to the right hand side, and so we're going to get 2 plus a half, which is going to be 2 and a half, which is 5 on 2, and this is going to equal 3 on 2 times root x. Multiplying both sides by 2, 5 is going to equal 3 times root x, which means root x is going to equal 5 on 3. Solving for x is going to be 25 on 9. And so the x coordinate of the point B is going to be 25 on 9. To find the y coordinate, we sub this value back into f of x. And so f of 25 on 9 is going to be 25 on 9 times 2 minus the square root of 25 on 9, which is 5 on 3. We can change the 2 to 6 on 3, and so this is going to be 25 on 9 times 1 on 3, which is equal to 25 on 27. And so therefore, the coordinates of the point B is going to be 25 on 9 and 25 on 27. Show that the graphs of f and g intersect only at the origin. To find the point of intersection of the graphs, we need to let the function f equal g and then solve for x. And so we're going to get x times 2 minus root x is equal to 2x. Expanding the left hand side, this will be 2x minus x times root x, which is going to equal 2x. Taking the 2x to the right hand side, we're going to get minus x times root x is equal to 0. Dividing by negative, x times root x is going to equal 0, which means that x is equal to 0 or root x is equal to 0. And solving for x is 0. And so this means the only point of intersection is going to be when x is equal to 0. To show that the intersection is at the origin, we also need to show that the y-coordinate is 0. To find the y-coordinate, we sub x is equal to 0 into any of the two functions. And so subbing this into the function g of 0 is going to be 2 times 0, which is equal to 0. And so therefore, the point of intersection is at the origin. 0, 0. Let q, where q is larger than 0, be a point on the graph of g. The tangent to the graph of f at the point D passes through q as shown below. It can be shown that D is equal to 3q. Determine the values of q for which the tangent to the graph of f passes through q and has an x-axis intercept greater than 4. The key information to note here is that the tangent to the graph of f has to have an x-intercept greater than 4. This can only happen if the tangent is going to be in the negative direction. In other words, the slope of the tangent line is decreasing. Looking at the graph of f, we can see that it has a maximum point. We know that the slope of the tangent line at the maximum point changes from increasing to decreasing. At the maximum point, the tangent line is going to be horizontal. A horizontal tangent line is parallel to the x-axis, and so it will never pass through the x-axis. Therefore, the point D, where we're going to have the tangent line to the graph of f, must be greater than the x-coordinate of the maximum point. To find the x-coordinate of the maximum point, we let f dash of x equal 0 and then solve for x. From part A, we found that f dash of x is equal to 2 minus 3 on 2 root x. And so if we let this equal to 0, we're going to get 2 minus 3 on 2 root x is equal to 0, which means 2 is equal to 3 on 2 root x. Multiplying both sides by 2, we're going to get 4 is equal to 3 root x. And so this means root x is equal to 4 on 3, and solving for x, this is going to be 16 on 9. And so the x-coordinate of the maximum point is going to be 16 on 9. This means that the coordinate D has to be larger than 16 on 9. And we're told that D is equal to 3q. And so 3q has to be larger than 16 on 9. Solving for q, we're going to get q is larger than 16 on 9 times 1 on 3. And so q has to be larger than 16 on 27. Now you need to be careful here, as the domain of f of x is from 0 to 4. And because the graph is not continuous after the point x is equal to 4, the gradient, which is also the slope of the tangent line, will not be defined at x is equal to 4. And so this means that the point D must also be less than 4. And so the coordinate small d is going to be less than 4. And so 3q has to be less than 4. Solving for q, this is going to be less than 4 on 3. And so therefore, the values of q are going to be from 16 on 27 to 4 on 3. Thanks for watching this video, and if you guys are interested in watching the video solutions to the rest of this paper, then join the Maths Methods Club, where you can get not only the solutions to this paper, but also to every Maths Methods exam question asked from 2006. And all the questions are grouped into 6 main topics and 35 smaller subtopics. This question was related to tangent lines, and so if you click on differentiation from the main topics, and then from the subtopics select tangents and normals, and then click on filter, what this is going to do is group all the past Maths Methods exam questions related to just tangent line questions. And so this way, you can focus on just one topic and strengthen your understanding on tangents and normals. If you wanted to break it down even further, you can break it down by tech-free, multiple choice, or extended response. And so if you click on tech-free and then filter again, this is just going to show you only the tech-free questions related to this topic. Go through these questions and see how you go. And if you get stuck, you can watch the video solutions. Good luck, and I'll see you guys in the next video.